Part 14, Triangle Centers and Quadrilaterals. Problem number 1. I see we've got orthocenter, circumcenter, centroid, incenter. Well, we need to make sure that we know all the information on this paper. For example, orthocenter, that's where all the altitudes meet. Okay, so orthocenter is going to be where the altitudes meet. So that's going to be A. Circumcenter, that's going to be where the perpendicular bisectors meet. Okay, so circumcenter is perpendicular bisectors. The centroid, that's where the medians meet. See, centroid, medians. So this is going to be C. Alright, and that leaves the angle bisector. That's where angle bisectors meet at the incenter. So that's going to be D. So just right off the top, once again, you need to make sure everything on this sheet of notes, starting with the connections between the words and the intersection of what. But you also need to know what a perpendicular bisector is, what an angle bisector looks like. You need to be able to recognize it by the picture. A median is a segment from the vertex to the midpoint. You should know it either in words or in picture form, and you should be able to connect it all back to centroid. All of these things go together. You have to basically memorize this paper and these properties down here, which we'll get to in a second. So far so good. Easy part's over. Problem number 2. R is the circumcenter. Okay, right away when they say circumcenter, is that the one that is equidistant from the sides, or is that the one that is equidistant to the vertices, or is that the one that has like 2/3 and 1/3 and the big part is twice as big as the small part? Which one is it? Well, if you don't remember, look back at your paper. Circumcenter, that's the one that is equidistant from the vertices. Okay, so that tells me that the following segments are all equal. Alright, this is the circumcenter. So if it's going to be equidistant to the vertices, that means these segments that I'm drawing now should all be the same. Alright, those 3 segments should be the same because it's equidistant to the vertices. Anyway, OS is 12. Okay, so this is 12. QR is 22. QR is 22. So this is 22. And PQ is 30. PQ is 30. That's all of this right here is 30. Now, the circumcenter is the intersection of perpendicular bisectors. So these lines that go all the way across, see how it's perpendicular? It's also a bisector, which means, I'm going to switch colors. Because it's a bisector, that means if this whole thing is 30, then this is 15 and 15. That means if this is 12, this is 12. Alright, that's the nature of a bisector. I said from the beginning that these 3 distances are the same. So if this is 22, that means this is 22, and this is 22. Now if I need to, there's a Pythagorean theorem that can be done all over the place here. but we'll cross that bridge when we come to it. Let's see what we've got so far. We're supposed to find segment OP. Okay, well, segment OP is right here. That's 24. We're supposed to find segment RP. RP is right there. It's 22. We're supposed to find OR. OR is right here. It is 22. And we are supposed to find segment TP. TP is right here. It is 15. Okay, that's how circumcenter works. Okay, let's look at problem number 3. D is the centroid. This is the centroid. Let's look back and see what we know about the centroid. The centroid is where medians meet. So the picture is like this. Notice all these lines touch the sides at midpoints because that's what medians do. So all of these are midpoints, so these segments will all be congruent to each other. What else do we know about the centroid? Center of gravity, yeah, that's not really going to help us a lot. This is the one where the centroid divides each median into a big part and a small part. The big part should be twice as big as the small part, and the big part is 2/3 of the whole thing, and the small part is 1/3 of the whole thing. So let's keep that in mind about the big part and small part. So let's see what we've got. DE is 16. Okay, I think I'm going to need a different color. And maybe I should make this bigger. Okay, DE is 16. Okay, so there's DE. So this is 16 right here. Now, that is the small part of this median. So I know that the big part should be double that. So if this is 16, then this part over here should be 32. Okay, I'm supposed to find CD. Well, I just did. CD is 32. I'm also supposed to find CE. Well, CE, of course, is the whole thing. Okay, so that's just 16 plus 32. So that's going to be 48. Okay, so we just needed to use that fact about the small part being half as big as the long part. Just double it. Okay, let's see what's next. Alright, point G is the incenter of ACE. Find GD and AF. The incenter. Well, the incenter is the one that's equidistant from the sides. Okay, looking back at our notes, incenter. We've got angle bisectors, but the main thing is the incenter is equidistant from the sides of the triangle. If I drew a circle inside of here, the center of the circle would be the incenter. So equidistant from the sides. Okay. Alright. Now, I feel a Pythagorean theorem coming on. But first, it's really nice how they have these distances to the sides all highlighted for us. So, if this is the incenter, the distances to the sides should all be the same. We know that one of those distances is 16. that means this distance will also be 16, and this distance will also be 16. All three of these blue segments should be 16. Now if I need to, I can do the Pythagorean theorem on any of these triangles here. But let's see what we're supposed to find. We're supposed to find GD and AF. Let's see. Well, GD is 16. It's right there. So we already found that. That's 16. Now what about AF? Okay, AF is down here. So here comes that Pythagorean theorem I was talking about. This is a right triangle. A squared plus b squared equals c squared. Okay, using the x, the 16, and the 34 as the hypotenuse. So here we go. X squared plus 16 squared is equal to 34 squared. So that gives us x squared plus 256 is equal to 1,156. Of course, we're going to subtract 256 from both sides. So that's going to leave me with x squared equals 900. Alright, so now it's time to take the square root of both sides. So if I do that, square root, that's going to give me x equals 30. So that is AF that we just found. So AF is 30. Okay, so that is what we had to do for problem number 4. Let's take a look at problem number 5. Okay, a mall is equidistant from each of the roads shown on this map, which could be used to find the mall's location. Now, this mall is supposed to be equidistant from the roads. Well, if we're going to be equidistant from the roads, is that equidistant from the vertices of the triangle, or is it equidistant from the sides of the triangle? Yeah, you guessed it. If we're trying to be equidistant from the roads, then that means we're going to be equidistant from the sides of the triangle. So, which one of these triangle centers are equidistant from the sides? Well, that's the incenter that's equidistant from the sides, so this one should be B. Okay, circumcenter, is this the line that's equidistant from the sides, or is it the one that's equidistant to the vertices? Vertices.
Yeah.
Circumcenter is the one that's equidistant to the vertices. So, you had to know that automatically in your head, okay? I mean, right now you could cheat and look at your notes, but come UACT time, you see circumcenter, you should think equidistant to the vertices. So looking at this picture, everybody, that means if this is the circumcenter right here in the middle, the distances that I'm highlighting right now, all of these three distances should be equal to each other. Okay? Everything that I'm drawing in red, those three distances should be the same because that's what it means to be a circumcenter. Well, that's one of the properties of a circumcenter. Now, it says some stuff. PC is 4x plus 5. So that tells me that this is 4x plus 5.
But it's actually 25.
Okay. It tells me that PB is 25. So PB up here is 25. Well, what should be the relationship between the 4x plus 5 and the 25? They're congruent, equidistant from the vertices. So you just make your little equation and go to town.
Oh, it's not valuable.
So 4x plus 5 equals 25. Good man.
At the bottom of that page.
At the bottom.
I found it.
Minus 5 minus 5, that gives me 4x equals 20. Dividing by 4, x equals 5. Okay? So that was problem number 6. We just did problem number 6. Okay, let's take a look at number 7. Which statement below is always true? Is every rhombus a square?
No.
No.
B is true.
This could be a rhombus. A rhombus just means all 4 sides are equal. If you make a nice diamond, a skinny diamond could be a rhombus, but it's not a square. So it's not A. Is every square a rhombus?
Yes.
Yes, sir.
Yes, every square is a rhombus because every square has 4 equal sides, which makes it a rhombus. So that's why number 7, the answer is B, because that one is true.
Now here's sheet number 14. No.
Yep, stand by. I'm already recording. You can walk over and get it yourself if you want. Looking at number 8. Which statement below is false? Some parallelograms are squares. Is that false?
No.
No, that's certainly true. Some parallelograms are squares. Some parallelograms are trapezoids.
That's true.
Is that true?
That's false.
That's false.
Yes.
Because of the way trapezoid is defined, a trapezoid is defined as having exactly one pair of parallel sides. Only one pair of sides can be parallel to be a trapezoid.
Parallel.
So that if both pairs were parallel, then it would be a parallelogram. But it can only be one or the other, never both. So that's the one that's false.
I like the way you say that.
I've tried to say it enough. That's the only way I can do it. Okay, looking at number 9. Corey drew a quadrilateral with 2 right angles, 1 obtuse angle, and 1 acute angle. So it has to have 2 right angles, 1 obtuse angle, and 1 acute angle. What's the answer? Which is the picture she could have drawn? Could she have drawn, say, a rectangle? Could it be a rectangle?
No.
Can't be a rectangle. That's all right angles. Could it be a parallelogram? Nope. It can't have 2 right angles and then an obtuse and acute. Could it be a kite?
Yes.
Austin's been saying kite the whole time because he's a genius.
Go us.
Okay? Imagine that we have a kite that's doing this type of thing. Okay? I didn't draw it 100% right, but I could have a kite where these 2 were 90-degree angles, and then this one could be obtuse, and this one could be acute. So it could be a kite. So it could only be a kite out of these 4 options. Okay, Jake drew a quadrilateral, PQRS, so that both pairs of opposite sides are parallel. Both pairs of opposite sides are parallel. Which one could not be the figure? Which one of these could it not be if both pairs of opposite sides are parallel? Why only Austin?
I should too.
And Connor, good job. Yeah, again, trapezoid. A trapezoid can't have 2 pairs of parallel sides. It can only have 1. So it could not have been a trapezoid. Okay? Which statement below, this is problem number 11. Which statement below is always true? Every parallelogram is also a quadrilateral. Is that always true?
Yeah, buddy.
Yep, that's true. Oh, I guess that's the answer then. It's A.
Whoa.
Yeah, right out the gate. Every parallelogram is also a quadrilateral. That's just common sense. Okay, look at number 12.
There hasn't been a C yet. This one C?
Yeah, first, right now we got
Which
bad ass.
of the following is not enough information? Which of the following is not enough information to determine that it's a parallelogram? Okay? Which one is not enough information? Let's see. One pair of opposite sides is congruent and parallel. That is enough to prove that something's a parallelogram. If you have one pair that's both congruent and parallel, it's a parallelogram. Both pairs of opposite sides congruent. That would prove, if they're both congruent, that has to be a parallelogram. One pair of consecutive angles supplementary. One pair will not do it. If it had two pairs of consecutive sides supplementary, that would do it, but not one pair. So that's why the answer was C.
The last one's D.
Number 13. Which of the following is not a property that a rectangle has? Which of these is not a property that a rectangle has? Let's see. A rectangle. Let me have a picture going while I'm talking about it. Here's a rectangle. Consecutive angles are supplementary. Yeah, it has that. These angles would be supplementary. These angles would be supplementary. The diagonals bisect each other. Yep, it has that. Alright. Diagonal, diagonal. They cut each other in half. Diagonals bisect each other. The diagonals are congruent. Yep, same distance from corner to corner. The answer must be D. Let's go ahead and read it just for fun. The diagonals are perpendicular. Nope, this is not going to be 90 degrees unless it was a square. A square would be the only rectangle that has perpendicular diagonals. Alright, and that is it for part 14.